Okay, please confirm you can see my screen and you can hear me properly.
Yes, Mr. Max, we can hear you now. We
Okay,
can hear
thank
you
you so much.
properly.
Okay, so chapter 3, it's something, it's very short, and it's not, if I say it's not difficult, student will say, Mr. Max, tell us it's not difficult, but at the end of it, it's difficult. Okay, this one is only theory. This one is only theory. And yeah. So this chapter, so guys, the most difficult part is what we did, especially on Saturday. The most difficult part. Anything else that we'll be doing now is much easier. So protocols and models, it's only how are we going to communicate? What agreement? For example, if I take Mr. Max and you, we meet Tuesdays and Thursdays. That's agreement number one. Agreement number two, I teach in English, not French or Shona or Lingala. You see that another agreement. And to pass your exam, you must. So protocols is a set of agreements. Let me take this one. Yeah, protocols is a set of agreement. So in a network environment where we have PCs, switches, routers, and all this stuff, if there is no agreement or protocols, how are we going to work to communicate? It will be chaos. That's why we have protocol to say, okay, if you want to send something, first thing first, you must have a network interface card. You must have a valid IP address. You must have a valid. You forget to receive all this stuff. That's all. So this one is the rules. How are we going to agree to communicate? You have a nice video and communication fundamentals and sender, receiver, and media. Who want to log on? Yeah, so that's about agreement, and that's about protocols. Like here, you see, all communications are governed by protocols. Before we communicate or we do something, we must agree first. So that's all. Anything else is only some readings. If something very important, for example, should I speak faster? Should I speak slower? Should I? And so everything. So this one is also readings. It's not a big deal. What is a big deal? I'll show you. Yeah, it's this one. Very important for IT engineers. So what is the difference between unicast? What's the difference between unicast, multicast, and broadcast? Message delivery option. This one is very important in IT. Message delivery may be one of these methods. Unicast, one-to-one communication. Mr. Max is here, and I'm talking to maybe Sharon only. You see, then it's a unicast communication. So in WhatsApp, we say DM, direct message, but in IT, we say unicast. So from time to time in our WhatsApp group, I'll say unicast me. It means talk to me only. Send me a message, a personal message. Don't post me the group. Then we have multicast, one to many. So Mr. Max is here, and I'm talking to the ladies only in our group. You see, then this one we call it a multicast. Or I'm talking to males only. Then we say multicast. Now, broadcast, Mr. Mark is talking to everyone. We say I'm broadcasting the message. So this one is very important, so you can check that. That's why in the questions I did send to you, chapter 3. So protocol, what's the protocol? It's a set of agreement. We agree on something. Now, question number 2, what's the difference between unicast, multicast, and broadcast? You should be able to give the answer. This is also an example of unicast and what. I'm going to check. We ask for job interviews and the exams and everything. Okay. We continue. This one is not so big deal. Protocols is a set of agreements, so this one is not much important. What is most important also is, for example, the web. People who want to use the web, we need some agreement, some rules. So for the web, if I type www.cisco.com and I press enter, what is happening in the background? Why should I tap www.cisco.com or what? Why? So everything is managed by HTTP, Hypertext Transfer Protocol. So this one governs the way of a web server and a web client will work. You are here, you want to go to internet, you open. So the rule is what? If you want to go to internet, you must do what? Open a web browser like these ones, a web browser. Then you type the address of a server, www.netaka.com. It means I want to contact that server. For example, it means I want to take a plane and go to, let's say, China. So this one means that I want to take a plane and go to China. If I press enter, then you're going to land. You see it's turning. Then now here I'm in China. Now that I'm in China, what do I want to do? In which town, which city? Then I click on the web pages. I navigate. So that's all for HTTP. It's going uh, to to set some rules about how web pages should work. HTTP. We have also TCP, we have IP, and we have Ethernet. Ethernet is the set of rules that will manage network cables, deliver message, network cables, and communication between your network interface card. That's why the normal network cable, we call it Ethernet cable or network cable. So we don't need to go in details what is happening there, but it's good to know HTTP is managing the web and all this stuff. So these are some of them. It's not all of them. We have many. Ethernet, anything related to cabling, HTTP for the web. TCP is about message delivery for conversation. So HTTP, TCP, IP, and Ethernet will be your new friends from now on. So you can read 1 minute and we continue. Okay, we continue. Protocols, weird. Okay, this one is not too much important. This one we'll do a bit later. So we see here, for example, Ethernet, anything related to network cables, and how the data will flow inside the network cable, anything related to network access, Ethernet. HTTP, anything related to the web. Okay, anyway, we'll have time to do that many times. So at a later stage, we're going to study each of them. What is ARP? We have a chapter for all of them. What is ARP? Chapter 9, I think. Ethernet, wireless LAN, this one CCNA3. We're going to start, we did study IPv4 already, chapter 11. Chapter 12, we'll study IPv6. Each of these guys, we're going to study all of them. So we do step by step. You can read this section. Okay, we continue. Something that is very, very important is standard organization. So we have big companies in the world that are going to say, how are we going to work in IT? So we decide and we apply. So please do some research about IEEE, IANA, ICANN, and all of this stuff. Anyway, we're going to explain each of them here. We have Internet Society. We decide if they say, okay, from now on, we don't need to tap www.cisco.com. You just talk and it will work. So we decide, all these guys. Internet Society, Internet Architecture Board, and you see, for us Africans, American we decide, then European we take it, then it goes down to Africa. So this guy we decide, and we, yeah. What is extremely important, you should know these two. What is IANA and ICANN? I think I didn't ask. I didn't ask here. And I'm going to ask. What do you know about, very important, IANA and ICANN? Extremely important. I'll send you this one later. So it's very simple. Just read. These are the two guys. We decide about IP addresses. How we format, like 192.168.200.27. All these dot stuff and why it's 4 blocks and what it this guy we decide. For example, South African ID. If you go to South African ID, what is it? This one, come here. Come here, South African ID. That's this one. Format. What's that? See? So for South African ID, the government will decide to give an ID to someone. The first six digits will be the year, the month, and let's say the date of birth. I'm going to zoom in. You see, the first 6 digits, it's for your date of birth. So if you're born 20 February 1992, 2002. So we decide, the government decide. The government will say, okay, we're going to add another 4 blocks, 4 digits. What is the meaning? If it's a lady or if a male, then so female, it will be between four zeros and 4999. If it were a male, between 5,000 and 999. Now the problem is some people they say they're not lady, they're not male. So now it's a problem now. They just decide. But the way when you were born, you are male or female. And then when we grow up, I'm not, okay, anyway. You see, so the government decide how a ID format will be. Then C, if it's 0, it means you're a South African citizen. If it's 1, it means you're a permanent resident. And the last one is something to validate something. You see, so this is an example of South African ID. The government decide how it will be. Same thing for IP addresses. These two guys will decide about IP addresses. Why we say cisco.com or netaka.com and domain name, we decide about that. And also some port numbers that we'll be doing a bit later. So this one, you can read and continue. Okay, we continue. Then here we're going to explain a bit. I did ask you these companies, please do some research. As an IT, it's very important to know them. What is TIA, ITU, IANA, and so here we're going to explain a bit. IEEE, what we do, TIA. So you can quickly read 1 minute and we continue. Okay, anyway, you can read it later and do some research. And a reference model, this is our friends until end of the year. So the physical layers, if you have such a network, these guys, we decided to group things in one place. It means anything related to the cabling, the media, Wi-Fi, network cables, all this stuff. We're going to classify them in the physical layer. So we have OSI, we call it the OSI model, Open System Interconnection Reference Model, is a way to classify anything we see in network in groups. We get to classify anything we see in network in groups. You see, meaning that anything anything related to with the media, network cables, Wi-Fi, fiber, we classify them in the physical layer. We have a chapter for that. In fact, we're going to do shortly in chapter 4. Anything related to a switch, MAC addresses, frames, we group them in the data link layer, layer 2. Anything related to a router, IP addresses, you see, we're going to class. Transport, for example, you want to sell, it will be TCP. DHL is more reliable. You pay more, but it's sure that you post office, it's very long, it's not sure. People can open your parcel, change stuff. You see. So transport, we're going to we have a chapter for each of them. Then session and presentation. So this one, OSI model, extremely important. We're going to spend a lot of time on that. So it's a way to group any IT things in a category or per layer. That's all. Some benefits. Okay, you can check this one. Okay, we continue. Now, here, this is a short description of each layer. Layer 1, physical layer. Layer 2, data link. Layer 3, network. Layer 4. So this is a short description, but we have a chapter for each of them. Let me check the questions. Yeah. So which organization is responsible for managing IP addresses in the world? It's these guys. IANA and ICANN. Now, what do they stand for? What is iOS, ISO, OC? You see, all this stuff, you should be able to know what they stand for as a network engineer. Anyway, to do your research, and you can Google because it's not an exam. iOS, Internet Working Operating System. This one is what? Let's say the Windows 10 or the Windows 11 that is in the router or the switch, the operating system. ISO, it's the standard organization that will organize also some IT stuff. You can Google it, you have a lot of. ISO is the standard with the 7 layers, layer 1, layer 2, layer 3, layer 7, and all this stuff. You can do some research for your own, but it's very, if you say what do they stand for, and TCP, IP, what is it? You should know what they stand for. TCP, I think, is transfer control protocol or transmission control protocol. So you should know them. So if you don't do something, you just do some research. That's all for now. So this is a short description per layer of OSI. You can also check that and we continue. But we have a chapter for each of them. Yeah, you'll get time to do that later. Okay, what else we can know? Okay, the main thing is that one. Anything else? Anything else? So we have the OSI as a model of organizing IT staff in groups. This is one way, and we have another way called TCP/IP. For them, this is how they're going to organize. Only 4 layers. But OSI, the most popular, is 7 layers. So you can also read this one. We continue. Then, yeah, that's all. That's all. Anything else we have time? This one is also very important. Data encapsulation. When you're here, You want to send an email and you press send. Your data will leave your network interface card and go somewhere. So you have your normal data at layers 7, 6, and 5. When it reaches the transport layer will add other information like who is going to send your data. Is it DHL? Then you're going to put a DHL to put the data in a DHL envelope. Now we're going to call it a segment. Then it will go down. When it reach the network layer, we're going to add IP addresses. Where do you come from? Where do you want to go? So because we added all this stuff, we're going to call it the packet. So you have your normal data on top, you see. Transport layer will add something, we'll call it segment, you see. When it reaches at the network layer, it's going to add IP addresses. Now this big thing is called packet. When it go to layer number 2, the switch will add MAC addresses, source, destination. Then we call it the frame. Then it go to a network cable to be divided in bits 01010101. And to go to a network cable, we call it encapsulation, putting an envelope in another bigger envelope. And this one, it's very important for a network engineer to know. Even if you don't understand for now, just keep it like that. We're going to repeat a lot, many times. So this one is very important. You can check 2 minutes. Anytime you have questions, unmute yourself, tell us your name, ask your question. Okay, we continue. So encapsulation. Okay, this one, just focus on this one only. Focus on this one only, it's fine. Did I ask some questions on that? Okay, binary, you should know binary. Binary is 010101. What is the difference between a byte and a bit? A bit is either 0 or 1. A byte, if you group 0101, a group of 8, like for example, 111000011. You see, if you combine 8 bits, we call it a byte. Right, with 7 layers of OSI. Yeah, layer 1, layer 2, layer 1, physical layer, layer 2, data link, layer 3, network, and so forth. Describe in 3 lines each of them, you know. You just need to come here. You see, it's explained here. Or yourself, you can Google it. You can Google it or go to YouTube and do some research if you want to. What is the name of a PDU, protocol data unit? PDU stands for protocol data unit. At the transport layer, it's this one. It's here. So you see, what is the definition of encapsulation? So at the transport layer, it's called segment. At the network layer, it's called packet. At the layer 2, it's called frame. At layer 1 of the physical layer, it's called the bit. Remember, this training is international. It's the same Cisco training for Americans, Canadian, European, Chinese, Africans. That's why it's international. When you get it, it can work anywhere. Protocol data unit and PDU. See PDU, protocol data unit. At the transport layer, we call it segment. At the network layer, it's going to add something else, call it packet. Layer 2, data link, is going to add something, we call it the frame. And at the layer 1, it could be bit. Yeah, that's the encapsulation is removing envelope. Let's say you receive a parcel, you remove the first box. If you see that inside you have another box, you remove it until you find what you want. It will go de-encapsulation. We're going to receive a bit, then always okay. Anyway, so it's not too much. Okay, normally that's all for this chapter. Anything else is a lot of readings. As I said last time, anytime you send something, two addresses are very important. Yeah, two addresses when you send the data in a network. Okay, I think today we'll do only chapter 3 and we'll do chapter 4 next time. What is that mouse of mine? Sorry, my mouse just vanished. I'm going to restart it later. Sorry, but my mouse is no longer working. No, sorry. Uh, mm, 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 yeah. So anytime you send something, your message will need two addresses: the MAC address that or physical address that will be used by the switch, and the IP address or logical address that will be used by the router. So for each of them, we have source and destination. You have, I think I need to restart my PC, it's becoming slow. So for each of them, we have source, destination. Where do you come from? Where do you want to go? Same thing when you want to send, when Tikalot want to send you something, source it come from Tikalot, destination, your address. So what is display here. Let me go again. So in this slide, we are focusing on the IP address. Always it should show where do you come from, source, where do you want to go. Okay, this one is not a big deal. We'll continue. Okay, this one we'll do later. So on top here, let me close this one. So you see, we have, so my mouse is not working and I'll restart my PC. Source MAC address, destination MAC address. These two will be used by the switch. Then the layer 3, that will be managed by the router, IP addresses. Source IP, destination. Where do you come from? Where do you want to go? Okay, anything else we'll be doing step by step, so no worries. So I think we are done for chapter 3 for now. Anything else we'll be doing that, no worries for that. Yeah, so you see here, when you send something, we always have two addresses, layer 2 address managed by the switch, it's MAC addresses. Then the other address is IP address that will be managed by the router. If one is missing, your parcel will not go, or your message will not go. Will not be delivered. Yeah, so let's say something like that. Yeah, so that's all. Anything else, you do some readings and yeah, so that's all for this chapter. So let's stop here for today. Chapter 3 only is fine. So you should know the definition of data encapsulation. And question number 11. What is data encapsulation? ASCII. What is ASCII? I'll tell you now. Veneto phonetic, you should know. Alpha, Bravo, Charlie, Delta. So ASCII is what? If I press on my keyboard the letter F for Foxtrot, how the PC will know that it's F? How your PC will understand F for Foxtrot? So it's a code, it's a table. So the ASCII, sorry, my mouse is no longer working properly. So the ASCII is a table that will give a value to anything. What A will mean, ASCII. So being a network engineer is not that's why people are very well paid. It's a lot of knowledge. Okay, you can read it. Okay. Come from Africa with this and us Africans, we just apply. What is my okay? I'll send you a link in the table. Yeah, you can do some research on ASCII table. My mouse is no longer working. Anyway, I'll send you a link for you to do some research there and view an example. Yeah, so let me put here. Yeah, so you see, so on your left side, if you press number 2 on your keyboard, the PC will understand binary, 0 like we did. If you press 10 on your keyboard, the system will convert that in binary. You see. Now, what if you press A or B or C? Then also we have a code for that. We still will say, okay, if you press A, it means search. I'm going to find it for you and send to you. Here, not what I wanted, but anyway. So, okay, let us stop here for today. So please go through the question for chapter 3, and you'll be fine. So next week, Monday, next week, Tuesday, we'll be doing chapter 4. Any questions?
It seems like we lost Mr. Mark. I think his network